The next lesson here talks about how do I know which measure to be using and what is going to actually affect them. So across the top here is kind of a little chart that gives you some information. Mean, if you are going to use the mean, you should use it to describe the middle of a set when there's no outlier, which takes us down here to this next box. So what is an outlier? An outlier is a number that is much higher or much lower than the rest of the data. We're going to see an example of that in just a minute. For the mean, one of the pros is that it's the most popular, it only gives you one answer, and it also allows you to compare other sets. The con for them using the mean is because it is affected by outliers. So if you have outliers, the mean is not the way to go. Median is going to talk about the middle of a set. This is useful when you do have an outlier because the median is still going to be fairly true. Outliers don't affect it. It's useful to compare. There's only one answer. The median just seems to not be as popular as talking about the mean. The mode, it's really common to use if the data is not numeric. In other words, if we don't have a numbered set of data. So for example, if we were asking people in our class what type of pizza they liked the most, pepperoni might appear 5 or 7 times compared to cheese that might be like 2 times, or ham and pineapple that might appear like 3 or 4 times. So the mode would kind of be able to tell us more about the most popular item. In that case, outliers aren't going to affect it, and the reality is with the mode that if you're working with a set of numbered data, the mode is not a good thing because there may be more than one answer, and we also learned yesterday that there might actually be no mode, so this may not even exist for any particular set of data. Take a look at example 1. A new building contains 10 rental apartments. They're listed here. The apartments vary in size. The rental charges are shown in the table. The builder plans to advertising using one statistical measurement that gives a fair representation of the monthly apartment rents. He's going to use the mean. Find the mean or the average rental. So what we have to do is actually add up all these values. So I have 480 plus 360 plus 600 plus 480 plus 1,800 plus 720 plus 600 plus 480 plus 3,600 plus 540. And I got a sum of 9,660, and I need to divide by the 10 because there's 10 apartments here. So my average rental, so my mean rental is $966. So why doesn't the mean fairly represent the monthly apartment rents? Hopefully you're thinking, we just talked about outliers. Holy cow, wow, we definitely have outliers here. So the set of data has outliers. And to kind of take it a step further, the mean rental is $966. If you take those out, look at all these rentals. They don't even approach $966. So the outliers raise the mean. And therefore the mean, as if you were trying to advertise apartments and said we advertise a mean rental of $966, you're going to totally miss reaching all these people who clearly need lower apartment rents. So if they saw $966, they're not even going to look at your apartment complex because they are looking for these lower numbers that are here. So really the mean is not going to be a good example of this one. In this case, this would be a situation where you're going to be better off using that median because that's going to make these outliers will not affect the median as much. Example 2, Sam was able to list his test scores from the first trimester to see how his math score improved. So here he goes, he listed them out. Which measures of central tendency would be affected if the 90 was changed to an 88? So let's take that off and let's make it an 88. So if we're looking, we have 1, 2, 3, 4, 5, 6 sets. So the median would actually be here, and in between 82 and 84 is 83. Even if this changes to an 88, there's still an order. So will the median actually change? Nope. Taking a look, we don't even have a mode, so that wouldn't change because there is no mode and there's still no mode. So the only thing that would change would be the mean. Because a higher number got replaced with the lower, the mean would go down. If we replaced it with a higher number, so for example, if we replaced the 90 with a 95, the mean would actually go up. So in our case, which would be the best measure of central tendency to describe Sam's test scores? Typically, you're going to see mean. Mean's going to describe the test scores fairly accurately. In this case, you also could kind of go with the median, because the test scores, that median, that 83, is going to be fairly indicative of how Sam was actually did in math class. The next question follows around a line plot. A line plot is a way to organize data along a number line. So you can see down here we have a number line. Each X that's on here is representing a piece of data. So these are line plots that show the ages of debate team members from a high school and a college debate team then. So when you look at line plots, one of the measures of central tendency is easiest to determine, and the one that I think is easiest to determine is the mode. And the reason that I say this is because these line plots are very visual. If each X gives you one representation, you're looking for the highest column because that's your mode. So up here it's really clear that the most kids were 16 on the high school debate team. In the college one, 18 and 19 are tied, so those would both actually be modes. So for determining the range of the ages of the high school members, so high school kids go up to 17 and go down to 14. So the range is 17 minus 14, which is 3. If we're looking at the college kids, we go from 20 to 18. So 20 minus 18, our range is 2. It now asks us to find the median age of the high schoolers. So the median can actually be done pretty easily. Your numbers are essentially in order: 14, 15, 16, 16, 16, 17, 17. So you can cross off one from the beginning, one from the end. One from the beginning, one from the end. One from the beginning, one from the end. There's my median. So my median age is 16.